Welcome viewers. So here is another example on the sum of n terms of arithmetic progression. In this question, we have the sum of the first 10 terms of an AP is 255. The sum of the first 10 terms of an AP. So now, from the first sentence, so we have S10, sum. We use Sn to represent the sum of n terms. So S10 from this question, and S10 equals 255. Now, the next sentence, the question says, find the sum of the next 20 terms of the progression. We find the sum of the what? Next 20 term of the progression. Meaning, after 10, the next term will be, after the 10th term, that will be 11th term. So now from 11 to 30 will be the next 20, 1 to 10. Then the next 20 will now be from 11 to 30. Now the question says, find the sum of the 11th term to 30th term. So we have to find, so now, meaning if you want to answer this question, and 11th term will now be your first term. If you want to find the sum of this next 20, we assume this is our first term now, so that this will be the last term. And since the common difference can be generated, and the first time here is the first time, but the common difference will be the same for all. Now, when you want to consider the next 20 now, this will be the first term. The common difference will remain the same, and we can use the formula again to generate the next 20 term. Alternatively, since the question says find the sum of the next 20 term, it means I can find the sum of the first 30 term, then I will just take the sum of the first 10 from it. Once I remove this first term, I have the sum of the next 20 term. Now, then the question says find the sum of the next 20 terms of the progression, given that the sum of the first 20. Now, in the question we are given the sum of the first 10. In the same question again, we are still given the sum of the first 20 term of progression is 1010. Now, meaning our S20 equals to 1010. Now, we can use these two to generate equation. So once we generate some two equations, then we solve the two equations simultaneously. I know from the two equations we can generate the first 10 and the common difference. Since this is the first 10, first 20, inside this we have this. Now let's write out the formula for the sum of n term. Sum of n term is Sn equals to n divided by 2, open bracket 2a plus n minus 1d. Now this is the formula for the sum of n term. Now meaning sum of the first 10 term will now be S10 equals 10 divided by 2, open bracket 2 multiplied by a, which is 2a, plus n is 10. Our n is 10. So that is 10 minus 1d, close the bracket. Everything equals to 225. Your S10 equals to 255. So 255. We do the same for this. So we have, let's simplify this. So 2 goes in 10. That is just 5. Open bracket 2a plus 10 minus 1, that is 9d, equals to 255. Now, instead of opening this bracket with 5, why can't we just divide both sides by 5 so that we can have this in simple form? So now divide both sides of this equation by 5. So when you do that, we have 5 will go here, so you have just 2a plus 9d equals to, so divide this side also by 5. 5 goes in 25, that is just 5. 5 goes here, that is 10. 5 goes in 5, that is 1. So this is 51. So meaning 5 times multiplied by 51 will give us 255. Now we have this equation. Let's call this our equation 1. Also, let's find the sum of the first 20 term again. Let's use that to form the second equation. So we have S20 equals 20 divided by 2. You know, we are using this formula. N is 20 divided by 2. Open bracket. 2a plus 20 minus 1 d. Close the bracket. Now, and everything here, S20 is 1010 equals to 1010. Now, divide this again. We have 2 in 20, that is 10. Open bracket, 2a plus 20 minus 1, that is 19d. Close bracket equals to 1010. Here also 10 is outside here. To reduce this into simple form again, we can just divide both sides of this equation by 10 so that we have it in simple form. So 10 here, you have this. So that is 2a plus 19d equals to 10 here, that is 101. This is our second equation. Now let's solve these two equations, equation 1 and equation 2. Let's take them together. So we have the equation 1 as a 2a plus 9d equals to 151. We have the second equation as 2a again plus 19d equals to 101. Now we can solve these two equations simultaneously by using an elimination method. Why suggesting an elimination method? The reason is because the coefficient of a are already the same. So we can easily subtract it, find the difference of two equations, and a will disappear. So now subtract this. So this is 0. 9 minus 19, that is negative 10d equals to 51 minus 101, that is 50. Negative 50. So divide both sides by negative 10 again. So we have d equals to negative 50 divided by negative 10, which is 5. Now we know the common difference. Let's put d in any of the two equations to get the value of a. So we are using equation 1. We have 2a plus 9d, but our d, okay, 2a plus 9d, but our d is 5. So that is 9 multiplied by 5 equals to 51. From here again, open the let's multiply. We have 2a plus 45d equals to 51. 9 times 5 is 45. Now to simplify this, we move 45 to the other side. So we have 2a plus, 2a equals 51 minus 45. And 2a equals to 6. Divide both sides by 2. A will be a equals to 3. Now, we know the value of a, we know the value of d. But the question says, find the sum of the next 20 term of the progression. Given that the first term given that the first 20 term is this. Now we know the first term, we know the common difference. So what's next is to determine the sum of the next 20 term. So we know the sum of the first 10. Now we generate the sum of the next 20. Now, as I said earlier, you can solve this question in two different ways. The first method, we find the sum of the first 30 because the question says we are given the first 10, 1 to 10. And the question requested for the sum of 11 to 30. If you want to generate sum of this 11 to 30, is very simple. And how do we do that? We assume that this this 11 will be the first term. So, and 30, the 30th term will be the last term. So, and also, the common difference is the same for all, which is 5. We just need to generate the 11th term. Once we generate the 11th term, that 11th term will now be the first term, since we don't need this again. The question requested for the sum of the next 10 term, which is 11 to 30. Now, what do we need to do? We find the 11th term. How do we find the 11th term? We use the formula for the nth term. Once we know the 11th term, we can easily, that 11th term will represent our first term. And our D is the same for all. So we can easily find the sum of the next 20 term. So let's see this. Now we know that Tn equals A plus n minus 1 D. So this is formula for the nth term. So now we want to generate the 11th term. We don't need anything, we don't need the first 10 terms, since the question is not requested for that. We only need from 11 to 30, which is the next 20 terms. Now, so we find T11 equals A, our A first term is 3, plus 11 minus 1, our N is 11, and D is 5. From here we have 3 plus 11 minus 1, that is 10. So 10 times 5. And 10 times 5 is 50. So here we have 3 plus 50, which is 53. Meaning the 11th term of that sequence is 53. That 11th term will now represent our first term. So now if this is our first term, we have A as 53, and we have our common difference D as 5, because common difference is the same for all. From the first term to any term you are moving to, your common difference is the same. Now, then our N, since we are looking for the sum of the next 20 term, it means our N this term will now be 20. It won't be 30. N will be 20. So now N equals to 20. Now let's generate this term by formula again, sum of the first 20 terms. So now 11 is now the 11th term is our first term. So we don't forget about the first 10 term. Now we don't know anything about them again. So we are only dealing with from 11th term upwards. So that 11th term is now our first term. So, and we generate the next 20 term. We find the sum of the next 20. So now from here now, so our S20 by formula equals to 20 divided by 2, open bracket 2A, which is 2 multiplied by A. Our A now is 53. Plus N, which is 20, minus 1, and our D is 5. We close the bracket. We simplify this further. So we have 10, open bracket, 53 multiplied by 2. That is 106. Plus, this is 19. 20 minus 1 is 19. 19 multiplied by 5. That is 95. Now we sum these two together. So we have 10, open bracket, this plus this. That is 201. With 211. This plus this, that is 1. So that is 201. Multiply this, so we have our S20 now. Sum of the next 20 will now be 2010. So sum of the next 20 term is 2010. This plus this, that is 11 carry 1. 1 plus that is 0 again, so that is 2010. And that is just the solution to this problem. Now, alternative method, you find the sum of the first 30 term minus sum of the first 10 term. Let's check if the result will be the same. So let me remove the equation. So now our S30, but now when we are looking for the sum of the first started term, so we don't consider this our first term again. We use the normal first term, which is 3, and the common difference still remain, which is 5. So we say our A is 3, our D is 5, and our N this time is 30. Since we know the sum of the first 10 term, we just subtract this to get. So N is 30. So now our S30 equals to 30 divided by 2, open bracket 2A, which is 2 multiplied by 3, plus N, which is 30, minus 1, and our D is 5. We close the bracket. So now this is the sum of the first started term of the series, if we start from the given first term. Now we have 2 here, that is 15. 2 multiplied by 3, that is 6, plus 30 minus 1, that is 29. 29 multiplied by 5, that is 145. 145. Now let's add this together again. So we have 15 multiplied by 151. So 15 multiplied by 151, that is 151, 15, 5, 25, 2, 7, 1, 5, 1, 5, 6, 2, 2. So that's 265. 2265. Now again, we want to look for the sum of the next 20 term, and we know the sum of the first 10 term. So our sum of the next 20 will now be S30 minus S10, and our S30 is 2265, and our S10 is 255. So we subtract now. So we have 2010, which is equivalent to, which is the same as this, and that is the solution to this question.